Hello everyone. In this video, I'm going to walk you through question 10, Q10 of part 4 of the ROF homework. To start with, we are given a asymmetric slab waveguide, and the waveguide is made of a polymer layer of thickness 1 microns, and the polymer layer is deposited on a silicon substrate at 1 micron optical wavelength. The refractive index of the polymer layer is 1.77. The refractive index of the silica substrate is 1.45. The refractive index of air, the cladding layer, is 1. So in part A, we need to solve out the V number and the asymmetry factors for TE mode and TM modes. And we need to find the propagation constant of the guided TE mode and TM modes of the waveguide. And finally, we need to plot the mode field distribution. Okay, so we are ready. Now I'm going to switch you to the video mode. You are looking at the video. Now I'm going to solve out the first you need to know the V number. I'm going to solve out part A first. We need to know the V number. The V number is given by K0 D and then square root of N1 square minus N2 square. And in this case, K0 is equal to 2 pi over lambda. So it is equal to 2 pi and then 1 micron. And before moving forward, let's construct the structure. So we have 3 layer, and the outermost layer is N of 3, N of 1 there. So this one is equal to 1.77, and this one is 1.745, and this one is 1. So the thickness here is 1 micron. The lambda is 1 micron as well. So what you can do is you calculate the K0. K0 is 2 pi over lambda, and then N1 square minus N2 square, and then 2 pi over 1 micron, and then times 1 micron, and then square root of 1.77 square minus 1.45 square. And by my calculation, this thing will end me up with 6.378. So this is the V number we got. And now we need to work out the asymmetry factor. We first start with the asymmetry factor for the TE mode, and it is equal to N2 square minus N3 square, and then N1 square minus N2 square, and then N2 is 1.45 square and 1, and then 1.77 square minus 1.45 square. So A1 here will be 1.07, and ATMO is equal to N1 divided by N3, and then to the power 4, and then here will be the same. So if you do that, then it will be 1.771, and then 4 times and then times 1.09. So by my calculation here, I got 10.5. So this is the uh, answer for part A of the question. Now, what we are going to do is to switch to part B. Before moving forward, we need to construct the equation for part B first. So first, I'm going to erase this part, and we are going to work out part B. So first, we need to find the B, the value of B. The value of B is, the formula for B is NE square N2 square, and then N1 square minus N2 square. And then this one is Kz, which is the propagation constant. And then N2 square, and then N1 square minus N2 square. And then N2 is 1.45 square, and then 1.77 square minus 1.45 square, and then Kz, and then K dot. Now, in the end, when we calculate the K of Z, we will express it per micron. So we should put 4 pi here, yeah, and then square. And the value of B we will find out from the PV curve. And the next thing I'm going to do is to show you the PV curve. PV curve, yeah, before moving forward, let me show you. The PV curve is like this. The horizontal axis is V, and the vertical axis represent B. B is this value, and you have a multiple group of line, and the outermost group is m equal to 0. This means the mole number is 0. And you have the second group, which represent m equal to 1, mole 1. And in each group, each line here represents certain asymmetry number. The outermost one is a equal to 0. The second one here is a equal to 1. The third one here is a equal to 10. So this is the preliminary information we need to have in order to solve the problem. Now, what I'm going to do is to erase the right box. I will keep this equation. I will keep it in the corner here. We will need it. So P is equal to Kz divided by 2 pi square minus 1.45 square, and then 1.77 square minus 1.45 square. And the value of B will be found out from the graph. So let's clean up the area here. And then we will solve out the graph one after one. So now let's take a look in the MATLAB. So yeah, now looking at the now you are looking at the PV curve, and this is computer generally the PV curve. The outermost group of curves represent mole 0. The second group of curves represents mole 1, and the third one represents mole equals to 2. And The vertical line here represent V is equals to um, 6.32, which is the value we have calculated for part A of the question. And the horizontal axis is V normalized frequency. The vertical axis is V, so-called normalized propagation constant. From what you can see here at each mode, we have multiple lines. The outermost line represents A is 0. This means no asymmetry. The substrate and the cutting layer are the same. The second line here represents the asymmetry factor equal to 1. And as I have already calculated, the asymmetry factor for us for TE mode is actually 1. The second curve, the third curve here represents the asymmetry factor equals to 10. The fourth one opposite represents the asymmetry factor equals to 100. So this one they are step by decade by decade. Now let's take a look in the crossing between the vertical line, which represent B is equals to 6.32, and the second curve here. And you can see the number here. The number here is 0.851. So I will write it down for TE mode. TE. The asymmetry factor is 1.09, and from what we can get, the B value is 0.85, and for TMO is 0.83. 0.83, and the B value is 0.83, and this corresponds to asymmetry factor 10. So asymmetry factor 0.83. I've already written it down. Now let me do a little housekeeping here. Yeah, we can. Okay. We are looking at the second line and mode 2. So from what I can get here, the value, the crossing here is at B equals to 0.418. And the crossing here 0.348. Okay, so now I think this graph is done. We don't need it anymore. We are going to feed you back to uh, the right board. Now you are looking at the right board. From the right board, I have written down the information I have calculate. Now I'm going to use this formula to calculate the KZ. So by substituting the value of um, the refractive index and plugging in all the number, and by substituting the value of B, for example, if we substitute the value of B to be 0.85, then you get the value for, by solving the equation, you get the value of Kz. And from what I can get, Kz here is 10.84 per micron. And I can also do the same for this one. So by plugging in the number here, I got 10 per micron. Yeah, I would say the unit is per micron. And here the unit is per micron. And similarly, if I plug in B equals to 0.834, I got, by solving this equation, I get 10.806. And if I substitute 0 B equals to 0.348 into this equation and then solve it for Z, I got 9.863. So these are the answers for part B of the question. Okay, part C. The wave distribution. What I can say is that I can redraw the structure. So this here is N1 equal to 1.77 and N2 equal to 1.45. The length here is 1 micron and N here is equal to 1. So if my understanding is correct, therefore TMO TE0 is like this. Now TE1 should be asymmetric. So I would say it can be, yeah, you need the right one. Yeah, this will be like this. So this is TE1 and TM, which should be something similar. This is TM. So I think the question is done. If you have further questions, please leave your question to the comment section. Okay, bye bye.